This last part here is going to talk about how to find the sample size required to estimate the population proportion. And so how many people do I need to survey in order to be able to estimate the population proportion? So it's not just as easy as, well, if it's normally distributed, the answer is 30, because I don't know how the population is distributed. So the sample size required to obtain a 1 minus alpha times 100% confidence interval for P with a margin of error E is given by this formula. P hat is a prior estimate of P. So P hat times 1 minus P hat times Z sub alpha over 2 over E squared. Rounded up to the next integer. So if it's a decimal, regardless of whether it would normally round up or down, we always round up when it comes to these sample sizes. And then if no prior estimate is available, then n is equal to 0.25 times Z sub alpha over 2 over E squared. Again, rounded up to the next integer. And the margin of error should always be expressed as a decimal when using these formulas, and we'll talk about that. So what is Z sub alpha over 2? Well, Z represents a Z-score, which means that if you need to pause this video to go get your normal charts, that's fine. I'm going to need to use these normal charts. Hopefully this doesn't time out on me from time to time on this video. So alpha is part of the equation used to determine the confidence interval. For example, a 95% confidence interval can be rewritten as 1 minus 0.05, which means for a 95% confidence interval, alpha is 0.05. For a 90% confidence interval, alpha is 0.1. So it's just whatever you had to subtract from that 100%, but you write it as a decimal. Therefore, Z of 0.05 divided by 2 is Z sub 0.025. This is asking for the Z-score such that the area to the right of that Z-score is 0.025. Therefore, the area to the left is 0.975. I think I'm actually missing a 9 here, but it's okay. We're using this example, so we don't have to worry too much. But it's just, this is the area to the right. So E is the margin of error, and like it said, it wanted it as a decimal. So if we're told we want to estimate within 2 percentage points, E would be 0.02. If we wanted to estimate within 5 percentage points, E would be 0.05. So an economist wants to know if the proportion of the U.S. population who commutes to work via carpooling is on the rise. What size sample should be obtained if the economist wants an estimate within 2 percentage points of the true proportion with 90% confidence if, in part A here, the economist uses a 2009 estimate of 10.7 obtained from the American Community Survey. So determine which of the two formulas we will use. The fact that there is a previous estimate tells me that I'm going to use this formula from above, this one with the P hat in it. So I'm actually going to write that down here so that way I don't have to keep scrolling up and down. So N is equal to P hat times 1 minus P hat times Z sub alpha over 2 divided by E 2 squared. So I actually have this written on notes next to me. I didn't just memorize that formula. So if necessary, step 2 here, determine P hat. So because I have a P hat, I'm going to write it instead of 10.7, I'm going to write it as 0.107. So P hat is 0.107. What does that make 1 minus P hat? Well, what's 1 minus 0.107? I get 0.893. And then I need to figure out what that other fraction is there that I'm multiplying this by. And so let's see here. First, we're going to determine alpha, and then we're going to determine E. So alpha goes back to the confidence interval. So if I want a 90% confidence interval, then alpha is 0.1. And E is written as a decimal. So they have to say something about the margin of error. They say within 2 percentage points, which means E is 0.02. So I'm on my way to plugging everything into this formula over here. I just need to find this Z-score. So let's start by taking alpha divided by 2. So 0.1 or 10% divided by 2 is 5%, 0.05. So I want to find Z sub 0.05. And whether you draw this picture or not is not necessary, but I want to know the z-score such that the area to the right is 0.05, which means the area to the left is 0.95. So I'm going to use my chart and look for, oh boy, I can't scroll, which area is closest to 0.95. So fortunately, I don't need to scroll because right there is closest to 0.95. So it's actually halfway between 1.64 and 1.65. And so what's halfway in between those is 1.645. And so I'm going to use that z sub 0.05 is equal to 1.645. So this fraction here is 1.645 divided by 0.02 for E squared. And so now it's just calculator work. So I'm going to take 1.645 divided by 0.02 squared times 0.893 times 0.107 and get that the sample size required, I round up to the next integer, the sample size required is equal to 647. So that is the sample size required. If there's a prior estimate of 10.7%. Part B says if the economist does not use any prior estimates. And so that would mean that I would use my second formula. So the second formula with the 0.25. So I'll write that down here. So N is equal to 0.25 times Z sub alpha over 2 over E squared. And so we actually already did all the work of Z sub alpha over 2. It's still 1.645. E is still within 2 percentage points, so 0.02 squared, I'm just taking 0.25 times that. And so on my calculator, when I take 1.645 divided by 0.02 squared times 0.25, I get that if no prior estimate is used, I need a sample size of, I rounded up, 1,692. So if there's no previous sample, the number of people that I need goes up greatly. So that's example 6. We can do this practice problem here. If you want to pause the video and maybe try it on your own, we can come back to that. But it really comes down to knowing which formula to use and plugging in all your numbers. So in part A here, I'm going to use the first formula, which means I need to know P hat. I need to know alpha so that I can find the z-score. I need to know the margin of error so that I can find E. So P hat is the previous estimate, which is 0.635. And then 1 minus P hat is 1 minus 0.635, which is 0.365. And then I need to find all this other information here. So let's see. I need to find alpha. Alpha is based on the confidence interval. So if it's a 99% confidence interval, then alpha is 0.01. And E is the margin of error 0.03. So let's find Z sub alpha over 2. Alpha over 2 is equal to 0.01 divided by 2, or 1% divided by 2, which is 0.005. So I don't want to lose that decimal. 0.005. And so Z sub 0.005 says I want to know the z-score such that the area to the right is 0.005, which means the area to the left is 0.995. So I might have to figure out how to pause this video so that I can find 0.995. Or actually, I'm very lucky because here it is right here. I need to know the z-score that corresponds to 0.995. So it's halfway between, what is that, 2.58 2.57 and 2.58. Yeah, 2.57 and 2.58. Halfway between that is 2.575. So z sub alpha over 2, let me see here, z sub alpha over 2 is equal to 2.575. And so that's what I'm going to plug into my numerator. 2.575 divided by E is 0.03 squared. So then I just go to my calculator and I type in very carefully 2.575 divided by 0.03 squared times 0.365 times 0.635 tells me that N is equal to, I always round up, 1708. So the sample size required is 1,708. And then if I don't have any prior estimates, then I use the second formula. So I use N is equal to 0.25 times Z sub alpha over 2 divided by E squared. And so Z sub alpha over 2 is still 2.575 divided by E is still 0.03 squared. So then I go to my calculator, 2.575 divided by 2 squared times 0.25 gives me my total. I did something wrong. What did I not do? Oh, I divided by 2, not by 0.03. So let's see, 2.575 divided by 0.03 is equal to that, squared is equal to that, times 0.25 is equal to 1841. That makes more sense. So 1,842 is what I'll round up to as my sample size required. So as you work through the homework, please let me know what questions